Hey everybody, and welcome back to Jim's Garage. In this video we're going to be looking at Terraform, and before you worry, it's not as terrifying as you might think. Initially when I first went down Terraform I thought it was going to be a real struggle to get all of this working, but thankfully it's just a few configuration files. So why might we want Terraform? Well, if you've been following my videos around Kubernetes and Docker Swarm, it can be a pain to set up your infrastructure one by one, even with things like a cloud init. So Terraform basically takes that principle of having something like a cloud init, or it could even be a standard virtual machine, and it automates that process. So by the end of this video, you'll be able to run a single command, a Terraform apply, and you'll have all of the virtual machines set up that you need for your cluster or for your Homelab environment. Now, Terraform is a great thing to learn because in many large organizations, it's used for large-scale deployments, whether on-prem and even in the cloud. And it's similar to Ansible, but not the same. Terraform typically is for infrastructure, Ansible is typically for the applications that will run on that infrastructure. And Ansible playbooks are great for making sure that states are met. We'll come on to Ansible later down the path, but this video we're going to focus on getting the infrastructure done first. So taking a quick view of the documentation before we get started, we ask the quite obvious question of what is Terraform? Well, Terraform is infrastructure as code. So much like we have things like our Docker Compose and our Kubernetes manifest files, etc., we can do the same thing for our infrastructure. In this case, we're going to be spinning up Proxmox virtual machines using Cloud Init, and it means that when we run our Terraform script, yep, there's a script with a CLI, and I'll come onto the installation in a moment, it means that that process is repeatable. So whenever we run that script, we get the same output, i.e. we get the virtual machines configured in the number that we want in order to spin up our cluster. So how does all this work? Well, typically, and as you can see on here, there's integrations for many cloud providers, but what we need is a plugin. So typically these plugins and providers are what give Terraform its flexibility. So a plugin is a bit like having a custom language that Terraform can interpret and can be used to do things. So we're going to be using one specific to Proxmox, and yes, there are more than one that you can use for Proxmox, and there's a whole host of others depending on the application or the process you're trying to fulfill. So whilst this is going to demonstrate using Proxmox and it's not quite perfect, there's a couple of bugs in it, I want to step back from that and show you the overall process, so that whilst I will be providing the config files for this, hopefully you'll be able to follow the process, and in the event that libraries or providers become deprecated, you should understand what's going on and be able to switch your existing setup to use those instead. So I'm now going to jump into a review of the script that I've put together, and then we'll go through all of the steps that you need to actually get this to run. We need to hop into Proxmox and do a little bit of configuration. We need to install Terraform itself and amend a few values. And you can decide whether you want to use something like Windows Subsystem for Linux to deploy this, or whether you want a bespoke VM. Regardless of what you choose, I'm going to be doing this within VS Code and using the SSH connection that I've shown previously to do all of this. So the provider we're going to be using for this video is the Telmate Proxmox. Now, I had quite a bit of fun whilst I was researching this video. Fun in so much as I was pulling my hair out and it didn't work. But thankfully, if we hop into this tab on their GitHub, you can see that as of 2 days ago, there's been a resuscitation of this project. And it's now almost working. It's working enough that I can show you how to deploy it, and I'm hopeful that over time, this is going to get better. There is a competing one by BGP if you want to use that. I haven't used it because this did what I needed to. And again, the point of this video is to show you how this all works and the processes so that you can replicate and switch between providers. And hey, you don't even have to use this just for Proxmox. There's a whole host of other applications you could use this for. But anyway, handily with this provider, as you can see on screen, it comes with some examples. And in here we get examples for Cloud Init, which I've based my example from, albeit this one doesn't work exactly as it should. That's because, as I said, the provider has become deprecated over time because the Proxmox API has changed with newer versions. And that's something that's probably going to evolve over time. There will be changes to the API, and unless the provider is changed as well, things just will not work as expected. Also, there's things for LXCs, PVs, which are just your standard virtual machines, and also Vagrant. I'm only going to be doing the Cloud Init for this one because I think it's the most sensible choice, especially when we're wanting to do things at scale. We get all the benefits of Cloud Init, i.e. a pre-configured virtual machine with all of the settings already applied. Go and check my video if you haven't. And then we get automation to replicate it. Yes, I know you only have to right click and click clone. It's a pretty simple process. But if you're doing this at enterprise scale, it would save you so much time. So I've just hopped over onto VS Code, and by now you should see in the bottom that I'm SSH'd into a virtual machine. Now this virtual machine I've just spun up, it's an Ubuntu server, and I'm going to use this to deploy the Terraform script. You can use whatever you want. You could even use that Windows subsystem for Linux. The first thing we're going to do, you might have guessed by now, is we're going to head over to our friendly extensions tab and we're going to search for Terraform. This is going to allow us to have nicely formatted code, and it should be able to do things like auto indentation, lint cleanup, all of that good stuff. So now that's installed, we can head over back to our files, and I'm going to copy over the files that I've created for this video. So by default, we're in the home directory here, and I'm just going to copy these files over now before we talk about them. So the two files that I'm going to use in this example, I've called providers and test Cloud Init. Now they both have the .tf file extension for Terraform. Now there's not technically any right or wrong way of doing this. I've simply created two files here, but you may create more. Say for example, you wanted a .tf file specifically for your secrets. You can create variable names and then reference them, a bit like you would do Docker secrets perhaps in a separate .env file where you can lock down some of the permissions. So let's have a quick look. So in the providers file you can see here, I've created a provider, I've specified a version, and then I've created a separate provider for something else. So the first one, which is in these Terraform parentheses, you can see that I've created a registry and I've specified a version. So this process is exactly the same no matter which provider you're talking about. And those providers plugins are what I talked about earlier. In this instance, I'm actually running registry.example.com, I'll come on to that in a moment, /telmate/proxmox. Now, the reason I'm doing this is because I've had to deploy the release candidate, which I showed before on the GitHub. That's the one with some of the breaking fixes that hasn't been published yet. But when that is published, I'll simply need to do this. I can delete this first part, and then it will go out to the web and it will pull down the latest version. So as I said, this probably won't work in the future, but the process is exactly the same. You'll need to just change the source and change the versions to match the version that you're using. A bit like in Docker where you have composed versions or you might have the latest version of a container, etc. You pretty much do a similar thing here. You will need to update this over time. However, to get this working, I've pulled down a local copy. I will show you how to do that in this video. It's pretty straightforward. We simply need to clone the repository, download and install Go, and then make it, and then we'll copy it over to this location that I'm showing here. This is a hard-coded local location, but hopefully you won't need to do this in the future. The second provider is what it says on the tin. It's Proxmox. So this should give you a clue about what we're going to have to do shortly. We need to go into Proxmox, we need to create an API token, and we need to reference it here. This is going to give Terraform access to our Proxmox cluster because it needs to have authenticated API access to generate the virtual machines. You'll need to make sure that obviously any firewall rules are taken care of, and whichever VM or machine you're running this from has direct access to Proxmox. So with the providers set up, we can hop into Test Cloud. And in the Test Cloud, it's a bit long because I've created two different types. I'll show you what I mean. The first one here you can see at the top is Cloud Init K3s Master. Now, this is because it's using Proxmox Virtual Machine QEMU, which is what manages virtual machines on Proxmox. And then the second one here, you can basically just give it a name you want. You'll see that this one's called master, and this one down here is called worker. Now, all of these are taken from the API available from Proxmox. I'll show you that now. The issue with that is this provider doesn't necessarily support all of those API endpoints, and like I said before, those are going to change over time. That can break providers, and again, you'll need to make sure that you stay up to date with the most relevant provider, and you may even need to change if they become deprecated. I'll show you how to do the update to that in a moment. The cool thing about this is we can specify a target node. So in my instance, I'm using my Proxmox Dell. I've got 2, remember, so just change this to the name of your node. Even if you've got 1, you're going to have to specify it. I've then given it a description, so I've just called this Cloud Init Ubuntu because that's what I'm going to use. Doesn't really matter what you do, but just make sure it's relevant to what you're doing for your own benefit. I've then given it account 3. So what that does is it means it's going to create 3 of these. Now that makes sense because we're doing a HA masternode setup, so we need 3. So it will run 3 versions of this Cloud Init and create 3 virtual machines. Now it's going to clone an existing Cloud Init template, and I've created this before in a previous video, so go ahead, make sure that you've got a Cloud Init already created on Proxmox. Now it starts to get a bit funny, and this is where things might change in the future. That's because I'm using a release candidate and it hasn't been stable unless I use exactly some of these variables. So the operating system is of type Cloud Init. That should be pretty self-explanatory. And then we get into the configuration of the virtual machine itself. So this is a little bit like when you create the actual Cloud Init itself, you need to specify all of these parameters. We're doing exactly the same thing here, so that technically you could create a Cloud Init machine from a template, but you could then give it more cores than it was originally given. So in my instance, mine were given 2 and 2 sockets, so 4 usable cores. But if I wanted to here, I could have 2 sockets and 4 cores and get 8 cores. It's really up to you. In my instance, I've set NUMA to true because I've got a dual processor system. I've set the CPU to be host, so it gets all the functionality of the host CPU. Memory set to 4 gigs, and then interestingly we have this here. Now this is just because effectively I'm running this in a loop because I've got a count of 3. And so what that will do is everyone will be named in sequence, so the first one will be 01, the next one will be 02, 03. You can tweak that to whatever you want. Moving down, we've got the Cloud Init. So remember, the Cloud Init is mounted as an IDE CD drive, and that's basically what we're doing here. The actual data for that is saved on my NVMe. So this is a storage pool on your Proxmox host. Typically the default will be local-lvm, but change this to anything that you might have chosen. Next, the SCSI hardware, so I've changed this to VirtIO SCSI single. And then the boot disk I've set to be SCSI 0. So basically in the block of disks below, this bit here, I'm saying create my drive, give it to SCSI 0, and then set that as the boot drive. It's a bit like what you would do in the BIOS to choose your boot device. Exactly the same principle here, but just for a VM. Now after that, we've got some of the Cloud Init variables. So here I've got my IP address. And again, we can take advantage of it being sequential. So each time this runs, it's going to bump the IP address up by 1. It's going to use the user of Ubuntu. And here's my SSH test key that I've created in Proxmox, so that when this created, I can then connect to it automatically through SSH using my terminal and the keys that I've already got set up. Next, we're going to repeat pretty much the entire process. However, all I've done here is I've tweaked the name and I've changed the number to 2. So we want 3 masters and we'll end up with 2 workers. And I've changed the name here to just be worker, K3S worker. Now you can tweak any of these, so make them larger, have more storage space, etc. And I really do recommend you go and check out the API so you understand all of the variables you've got at your disposal. This doesn't just have to do VMs, it can do all the other things that are available through the API, provided that the provider supports it. So this provider, because it's sort of semi-deprecated a few weeks ago, it's now being given the kiss of life. But things like the BGP Proxmox, that seems to have more of the API available to it, and it seems to be better supported at the moment. So now let's jump into how we're going to use this. So the first thing we're going to need to do is to hop into Proxmox. We're going to have to get our API key, which I showed a moment ago. We're then going to need to install Terraform itself onto the virtual machine. And I'll then show you how to pull down and clone this test copy in case you ever need that. Hopefully in the future, like I've said, you won't need that. And then we're going to get into the Terraform API, have a bit of a play, and then we're actually going to deploy this and see what comes out the back. So over in Proxmox, and you can see here I've got selected, this is just a VM I've spun up for this demo. But to get this working, we need to head over to the data center, and we need to click on permissions and then API tokens. Now, I've created here this new one, token name Terraform, and to do that I clicked add. Then I've chosen the user as root, I've unticked privilege separation, and then I've given it a name. In this case I gave it Terraform, and when that completes it gives you this here. So for example, if I create Terraform 2, untick that, we should get a code that only shows once. So you need to take a reference of this code, keep it safe, and you need to add it to your script where I showed you earlier. That would be over in the providers, and it would be this value here. Now that we've got that set up, there's nothing else that we need to do in Proxmox. I would recommend you check just to make sure that you've got a cloud init template. In this case, I'm using this one here, 2304-non-kvm, and if we go back, you can see that I've referenced that in this test cloud init here, and it's called this one here. So that's where that value came from. Change that to whatever you've got. So now we've set that up, we're pretty much ready to go. And Terraform is a doddle to install. So if we head over to the official website, there's a handy command that we can grab and paste into our terminal. And so over on their website, we can see that we've got different installation instructions for different operating systems. The one we want is here, Linux, Ubuntu Debian, or whatever you're using. I'm simply going to copy this. I'm going to head back now into my VS Code, and I'm going to paste that command into the terminal. Hit return. That's going to go away and install now. It shouldn't take too long. It's quite a minimalist install. And once that's completed, we should have the Terraform installed with the Terraform CLI available. It might require us to update some libraries, so I'm just going to hit OK. You might want to reboot just to make sure. I'm not going to bother in this video. But now we should be able to do a Terraform -version, and we should see that we've got that now available. So we can see that I'm running 1.7.1 on Linux AMD 64. Great. Now, in an ideal world, I should just be able to run this script, and it's going to go and pull down this provider. Now, what we typically would need to do is simply a Terraform init, that is initialize. And what that will do is check these providers and pull down that provider. So it can't do that because I've specified this one here, registry.example.com, and that doesn't exist. If I change this to the official one, which again isn't working at the moment, so if I save that and I rerun that command, it should go away now and pull it. So there you go, you see it's pulled down 2.914, which on their GitHub is the latest version. However, this script here won't work because this is using the format for the release candidate. So how do we fix that? This might be useful for later on. Well, we're going to have to hop back into the command line and we're going to have to do some installation and makes. So the first thing I'm going to do to make this is to pull down and clone the GitHub repository. And I'm also going to create just a test folder, this Terraform provider Proxmox. So when I've cloned that down, all of the files necessary to build should be there. Now, unfortunately, I can't click make because I need to install Go because this is written in Go. And so to do that, it's a sudo apt update and then an install Golang. So after this is done, we should be in a position to be able to make. And so now with that completed and we're in the right folder, we need to install make, so sudo apt install make. Once that's done, we should be able to run the command make, and we should be able to build this release candidate of the provider. So if we run make, that's now going to go away and build the provider, and I'll see you on the other side. And so now that's completed, we need to create a directory that it expects plugins, i.e. local ones, to be in. And so that is terraform.d in your home directory, /plugins/ and we're calling this one just registryexample.com, /telmate /proxmox version 1, and then we need to put at the end Linux AMD 64. Now that I've created this, and I'll drop a link in the video description for where to find these instructions, we're ready to copy over the binary we created in the previous command, and then we should be good to go. So now if we look in the folder we were in, and then we go into the binary, the bin, you can see that we've got this file here. This is the release candidate. So we need to get this folder here, we can copy it, and then we need to go into the folder we just created here. So that was Terraform D, plugins, registry, Telmate, Proxmox, and it's this folder here. So hopefully now if we paste it into this folder here, you can see that it's there. And now when we run the Terraform init, again we want to go back to here. I'm going to undo on this command so it points to registry.example.com. I'm going to save that, and then back down in here, if I do a Terraform init, it should now go and find that. It would be handy if I was in the right directory, so I'm going to go back, and now if I do a Terraform init, it should go away and find it. So here you can see it's finding registry versions matching 1, and it's installing it here. So now it's installed the one we just compiled using the latest version, that release candidate 1, and it's not using the one that's available, that 2.9.14. Excellent. Well, what do we do now? Well, we're pretty much good to go, and I know that because I've run this earlier, but there's a few things you might want to do first. So one thing that's really important is something called Terraform plan. So this is basically a dummy run. So let's have a look at that. So I've run that, and it's going to say now what it's going to do when I actually run this. So this should be pretty straightforward, and it's quite long. That's because it's creating 5 virtual machines. But here you can see it's creating the first virtual machine, the second, the third, the fourth, the fifth, and at the bottom it should say it plans to add 5. So there's 0 changes and 0 to destroy. That's because it's queried what's on Proxmox already, and there's nothing there that needs to change or be destroyed. That's because we've not created it. So what do we do now? Well, now we're ready to do Terraform apply. So now we are applying this config, that Terraform file, to my Proxmox. So I'm going to hit return here, and when you do that, you're going to be asked to confirm this. There is an option to do this silently, and I'm going to hit yes. Now I'm going to quickly say yes, and then Alt-Tab into Proxmox. You'll see here that it's creating, and then if I go over to my Proxmox, you can see here that it's creating those machines. So now we've got master 03, worker 01, master 02, master 01. And if I go back to VS Code, you can see here that it's being created on the left. It's still creating them. And if we actually look at one of these machines, so let's take the master for example, if I go to the hardware, you can see that that all looks right with the credentials and the specification that I put within the Terraform script, and it's also using this cloud init here. Now, there's a few little idiosyncrasies with this, I think just because they're still doing the teething on the release candidate 1. For example, the cloud init is in IDE 3, and when I've run this, I've also got this spare IDE drive. I'm not sure what that is. And I've also lost the ability to have SSD equals true on this, and also the discard option. I'm hopeful that will be fixed. But if I actually hop into this, into the console, so you'll see that they were automatically deployed and started running. Hopefully in a moment this will pick up what's actually being put out, and we'll see this booting up as normal. Hopefully I can then log in, and I'll have access to it as though it was created simply by right clicking here and clicking clone. Now if I go back into VS Code, you'll see here that it said apply as completed, resources 5 were added, and that's correct. You can see that over here I've now got my entire K3S cluster up and running. Well, at least the infrastructure's up and running. And that's right, you can see over here I've got the 5 virtual machines running. K3S isn't installed yet, but as we know, this is the precursor. And if you were to now combine and run the script, you get the point. You've automated your virtual machine installation, and then you can automate your K3S deployment on your automated infrastructure. How powerful is that? Eventually, you can probably see where I'm headed. I want to have a script that I can run that will run Terraform, it will deploy the infrastructure, and then there's Ansible, and it would go and deploy the cluster. That means we would have a single-click solution for a bare bones installation of Kubernetes across high availability. So hopefully that video was useful in taking the sting out of learning Terraform. It's a really powerful tool that you can use to automate the provisioning of new infrastructure within your Homelab, and it's a valuable tool to understand for the enterprise. Now, as I've said, and I'll stress it again, this probably won't work long term in the future. The APIs will change, the providers will change, and you will need to stay on top of the configuration files. That's something you'll need to manage in your own time. I will try to keep the GitHub up to date, and I do welcome some PRs to help me on that. And do note that there is a lot of work going on at the moment to try and get this plugin back alive and out of that release candidate stage. Anyway, thank you very much for watching. I'm going to be using this in future videos to hopefully one day bring you the single one-click installation of Kubernetes. That'll be creating your infrastructure, those bare VMs, to installing K3S or RKE2 through Ansible. Anyway, if you've liked this video, give it a subscribe, hit that like button. Let me know in the comments below if this is something that you're going to use, and I'll catch you on the next one. Take care, everybody.